All right, for people joining this live stream, we are talking about code assistance for Wolfram Language. And let's take a look. Where are we starting off?
So as a background to a lot of code assistance stuff, there will be a discussion about parsing and the underlying linting technology also that I think also needs design reviewed, proper names and all
Have
that.
you guys looked at Chris Cooley's stuff about ASTs for external languages?
The code analysis Packlet?
Yes.
Yeah, it's a little bit different because that's very, very specific to C and C++. And there's, yeah, I mean, it's a different beast.
Well, what do we learn from it?
I'm not sure.
Okay.
Because so we're also using, we've in the compiler group, we're using Clang Link as the way of getting access to Clang and its parser and everything. So it's just, yeah, I mean, we have different.
Well, that's what I think. That's what Chris used is Clang.
Well, but not. I mean, but he didn't. Yeah, but I mean, we're not using that. We're using another. We're using a different layer on top of Clang. But
look,
I mean,
he's already worked on something very close to this. It will be really useful to understand what he's done. Okay, but let's take a look at what you have here.
Sure.
Okay, this is going to be a complicated design problem.
Sure. Yeah.
I mean, it also relates to the way of tagging text with text elements and so on. All right, okay, but let me just understand the structure of this meeting. So we've got some AST representation, and there's a question how that should work. Yeah, this isn't even close. I mean, there's a lot of work to be done for this. I mean, it may or may not be user exposed, which means it may or may not be worth, huge design effort, and we may not be ready to do huge design effort, and it may not be necessary for what we're trying to achieve.
Well, I know that this is, big wall of text imposing, but the functionality, it's largely all here. It's a question, I was wondering about this meeting, it could be a question of going over names of things more.
Oh, but look. The other thing you haven't done is to look at how this relates to the tree project. Right, we've got a whole project about, analysis of trees, which obviously these are, right? And so those have a whole bunch of things to do with, that's Jose's project. Maybe we can see if he can join this meeting. Can we find out if Jose and or Chris Cooley can join this meeting? Somebody do that, please.
Yeah, I'll try to grab them.
Okay.
But just as an overview, yeah, if you keep, so just about parsing, which we may not even really need to talk about, and then linting, that I'm more interested in getting your opinions on. And
okay,
then,
well, so wait a minute. There's
assistance.
Okay, what have you done so far with the? What's happened with the line formatting stuff? Is that what's part of this, or is that something different?
Yeah, no, that's this. But so as a preface at the very top, I don't want to get into the specifics of how to break lines and everything. I wanted to be talking about the inputs and outputs and names of functions that would be exposed to users.
But I got to see what they do before we have any idea what those are going to be. I mean, okay, so let's take a look here. Okay, so we already have multiple parsers. So this is another parser. Is that correct? Or is this a parser that's going to use the same front end as some existing parser?
No, it's another parser.
Is that a good idea?
Well, I think it is. I mean, I might be biased, but so I've been spending a lot of time on it, and this more so than both the kernel and the front end parsers has been hardened and bulletproofed and tested to a greater extent, and has actually helped find bugs in both the kernel and the front end parsers by comparing, what they both do separately.
How fast is this parser relative to those ones?
Well, so a lot of this is in top level right now. And so speed, I don't even want to talk about because you don't compare the speeds yet. But I'm slowly moving more and more stuff to native code when we could talk about speed, but a lot of this is in top level. And I mean, there's just no comparison of speed right now.
Okay. But I mean, it's not too relevant to what you're doing.
Sorry?
That's not the most relevant thing for what you're trying to do, probably. Yeah. Okay. So the output from this is an AST. What's the idea of that? How would that? I mean, are you imagining that one day this becomes the standard parser that we use, or what?
Well, yes, but not this output because, I mean, parsing directly to expressions is what is needed, obviously, for replacing any extent parser. But this serves a purpose for users wanting to build their own tools that it is a problem of reinventing the wheel, many times, many different parsers. But the advantage of this is that this is all written in higher level C++ modern code and top level code that benefits from, just being newer and cleaner. And I have
okay. So is it a complete parser?
Design goals. Sorry?
Is it a complete parser?
It is absolutely complete. Yes.
No, including all kinds of multi-byte Unicode, and it deals with all that stuff.
It deals with all that. This has features that are hard to add to the other parsers that we want. So if we want a profiler or a coverage tool, this parser is a good thing, maybe to improve the debugger. This parser is a better way to implement things like that. It's more flexible and easier to extend. And those are things we want.
And so it's tricky. So for example, if you're saying \::, to give the parser an actual \::, making sure to escape the \/ into the string. So, but yeah, no, you can feed it absolutely anything, even syntactically incorrect code, and it will return something intelligible. Like if you just evaluate that right now. Something comes back, I mean, various things saying errors here and there, but, so. But yeah, no, it is absolutely a complete parser.
Okay, so how would I turn that into an expression?
So yeah, that's one of the questions that I wanted to address today of what those functions would even be called. Right now, you could say to full form string of AST to get the string back. I mean, but so.
No, I don't want a string. I want an expression.
Yeah. So the question is, so I have these functions, parse string and parse file and parse bytes for byte arrays, and I wanted to go over what the function names. One of the items below is what the function should be for parsing directly to expressions, and my first iteration is parse to expression, and whether or not that would be a good idea, because then.
Well, it's the same as to expression. I mean, it's the same. It's a method option for to expression.
Sure, that could be yes, yeah. That's another way of saying it. Yeah.
Right. So, okay. So how do I display this in some way that I can understand what's going on?
Yep, that should work. Now, there's a lot of metadata. The source information clutters that up, but you can definitely see the structure.
Well, do you have some visualization tool for this thing?
Not different than tree form, no.
So probably you need a version of this that is a cleaner version, which doesn't those source tagging things that gives string positions and things.
Yeah.
Should be elided in some way.
Sure.
And yeah, I think it would be useful to give this, and I mean, I would model this on text structure, which has a way of displaying syntax trees effectively for natural language. Okay. Okay.
Yeah. So all of this is fine.
So
along with-
it captures comments, yes?
So parse by itself is supposed to be abstract syntax, and you will not see a comment. But if you said concrete parse string of that, you will get the comment back, for example. So if you if you evaluated that and then replaced parse string with concrete parse string.
I don't understand why you wouldn't want to keep the comment in the generic AST parse.
Well, that's not part of abstract syntax. That's what makes it abstract. That's for example, one of the differences between concrete and abstract syntax.
Yeah, I don't care what it's called. It's the question of how people will actually use this.
Well, I mean, but if you want comments, you would say you would be dealing with the lower level.
It's a bit similar to the strip boxes before you you convert boxes to expression.
Yeah.
Some of the boxes are not valuable for the kernel. They don't mean anything for the kernel. That's what a comment is. Kernel doesn't care at all about the comment.
So yeah, I mean, this is an illustration of the difference between the two, for example, and white space and stuff like that.
But if you want to add brackets in a broken expression, you are interested in comments and all the things that decorate your expression.
Or formatting.
Or formatting, definitely.
Yeah, exactly.
But if you want to do profiling, you don't care about that, or debugging, you don't care about that.
So you need both.
You need both.
Programmatically.
And so maybe it's a question of which one does not have the prefix. Maybe parse by itself.
I don't understand why this doesn't record its source here.
The plus symbol was invented.
What do you mean? The plus symbol is right there.
No, that's not that's not the plus symbol.
Okay, where is
There's
the plus
no head
sign?
plus.
Where is the plus sign in this whole thing?
Well, this is the exact same result.
The concrete.
No, I understand that. I want to know the answer to you're recording in this case what the string source positions were for those elements, right?
For the leaves, yes.
Where's the string source position of the plus?
It's not, the plus signs source position is not in here.
Why?
Like the comment.
Exactly. It has been abstracted away.
Why? I mean, it has a position, right? Just like you know that the 1 has a position, the plus has a position.
Well, the one has the same representation in both, like that's a leaf node. The plus sign is not a leaf of the tree.
So?
And if you care about the plus sign position, for example, you would also want to do concrete parsing.
I don't understand. I don't see why it's any less concrete. I mean, any less amenable to the abstract description.
So if you said parse string of, head, like symbol plus 1, 1, you would get the exact same output as what you have there. It has the exact same abstract, square bracket, same output. I mean, different source location.
No, right there, it says where the plus is.
The question
right there.
Well, there is a symbol.
But it doesn't say where the
there.
bracket. It doesn't say where the bracket is. You see, there's no.
All right. Okay.
Yeah. If you do concrete.
Okay. I understand,
yeah, okay,
Tom.
fine,
I understand.
Fine.
I got it.
Yeah, no, I mean, these are all good differences between, yeah.
Right, now the open brackets are in there, you see.
What's group node?
The group of the square brackets is...
What's group square?
So we don't have a symbol in the language to represent the token of open square bracket and closed square bracket. So I had to invent a symbol.
Why don't we use the string, quotes, open bracket for this?
We could.
That way we can understand what's going on.
We could. Yeah, but it's just supposed to be.
Well, it should be an adorned string, maybe like token of the string.
Yes. Well, how does that relate to the way that tokenization works for natural language and text cases and text structure?
I mean, just different engine.
No, that's not good enough. I mean, it's not good enough to just say it's different, right? You got to understand what, I mean, so something like this is a very similar concept to what you're doing.
Can we see the input form of that? Yeah.
Yep, it's text elements.
Yeah, but in natural language we have only one world, which is the world of what is written. We don't have the word of what is meant as a structured things.
Well, we actually do have some of that. We have noun phrases. We have all kinds of things like this.
No, but we don't. In terms of meaning, that is, in terms of if you'd rather have it as the word vectors, which is what
no. We could perfectly well have meaning for these things, just like we do if we parse to an entity. We would have meaning for that. What text cases does generates meaning from natural language. It's not as different as you think. Okay, let's keep going. Let me get the bigger picture here.
Yeah. So everything you were doing applies equally to files.
I get it.
Concrete stuff we were talking about. So
can somebody pull up Chris Cooley's version of the AST system? I mean, I worked a bit on the design of that. Did anybody look at that design? No, I'm sure you didn't. Okay, this was from 2016. Did we manage to find Chris?
No, we couldn't get him. I don't think he starts working for another couple of hours. But we do have Jose.
Okay.
Yeah, right here.
Okay, well, that used to be a call graph there. So, okay, we're looking, Jose, at abstract syntax trees, and I'm trying to understand how they relate to our other tree stuff.
Okay.
So the tree element mechanism, do you have the design of the tree element mechanism?
Let me think. So we have an implementation in the X kernel.
That's what I'm running here. So what would be an example of what I do?
Try expression tree of some expression.
Okay. Okay.
Yeah, so this is following text element.
Okay. You guys can see why I thought this was relevant, yes?
No, it's relevant.
Okay. So now if I want to, what is the none doing there?
So that's annotation for the final leaves.
I see.
Yeah, in the representation, we also distinguish the square notation from the slightly rounded corners for the heads.
Right. So in particular, we should be able to take one of these creatures here. If I say parse string, I should be able to say expression tree. Lovely, lovely. Now, what does that mean that it's saying I see. That's a...
That's
So
kind of
some
interesting.
notes for associations and lists, I think we decided that it was not worth having.
I see.
Yeah.
Right. Okay, that's actually quite useful. Okay, I get it. So that's the metadata of the call node. That's the that's the list of the contents of the call node, which is analogous to that element there of tree element, right? And in tree element, more like XML, the metadata occurs in the first argument, in an association in the first argument, right? That makes sense to people?
Yep.
Brenton, you understand?
Yeah.
So what you're doing here, the difference here is, in principle, one could represent this stuff in terms of tree elements by just, I mean, it's a very straightforward transformation, right? Because you would take these nodes, the name, the type of node would be in that association that appears first. And then, as with things like the source metadata and so on, right? Am I correct?
I mean, I don't know what the intentions are with tree elements. I mean, it sounds right. Yeah.
Yeah, well, the intention is to have a standardized representation of trees in the system.
Well, is that not, well, so if you scroll up in the notebook that you're in right now, no, with the plot you were just in, the other, yeah. If you scroll up, I mean, the argument to expression tree that you gave f of g of x and everything, like that is a tree. And so I'm not 100% clear on what the tree
this is essentially an abstract, this is a way of doing the kind of thing you're doing. This is, think of this as an abstract semantic tree. Okay, that term, why did that not do anything? Oh, because it's not a string.
Yep.
Right. Okay, I get it.
Yeah, and maybe they're even completely isomorphic to each other.
Yeah, well, that's what I'm thinking.
Yeah.
But I mean, the real question is, we're going to have a bunch of tools for manipulating trees in in the tree element form. And so obviously those could be used, a lot of manipulation functions to do with tree substitution and so on. And obviously one would like to be able to reuse those things.
Yeah.
And also it provides a way, but I mean, the issue really is what kinds of transformations are important here. All right, let's keep going here. So what you're effectively doing, I mean, are we going to admit that the thing is a tree? Probably. I mean, let's imagine that what you were to generate was a tree object here.
Mm-hmm.
With all of your, with everything here, but a lot of the stuff that's here would turn into strings and so on that would be part of the metadata of essentially the tree element. Let's imagine it was something like this. I mean, I'm just where basically all the metadata is put into that head association, and then it's the same exact structure as this.
Yeah.
So, I mean, essentially what this would be is something which says, I don't know what, I don't know what it would say, but something like, there'd be a leaf, there'd be a type arrow leaf, et cetera, et cetera, et cetera.
Is there something to reverse expression tree?
Yes, I believe it's called tree expression. There it is.
Great. So it'd be quite nice if the output of parse string, if you did tree expression on it, it would give you the expression. Can you get it back wrapped in hold?
I'm sure you can. I'm sure you can.
I mean, yeah,
obviously,
detail.
what's that? Yeah, right.
I mean, if you can't.
No, I mean, do we have some kind of guide page of the tree operations, Jose?
I think we started writing one. Let me check.
Okay. Because I just think, this is what you're going to need to edit parse trees, and we've already got a bunch of that functionality. But what I'm concerned about is how to make the patterns convenient. I mean, that's what we tried to do on tree expression, tree elements.
Absolutely. It's a problem, yeah.
Right. Well, so that's what we were trying to do with tree elements, and that's why we ended up with the structure we ended up with, is to be able to write the patterns in a convenient way.
Yeah. I mean, the linter is a testament to how cumbersome it is to do this kind of thing.
Okay.
To write patterns in this language. Yeah.
Fine. Okay. Well, all right. Well, maybe the tree element will help. All right. So I think I understand this. And
there's another metaphor, which is the depth first scan and breadth first scan functions of graphs is another metaphor for this.
Why?
Because they navigate down through trees.
And they're a mess.
Well, I'm just saying that's another thing we have.
Mm-hmm. I mean, particularly breadth first is a horrible mess in terms of what action it takes at each step and how it decides what to do next.
Stephen, can you open a featureized guide page called Trees New? Trees New. That one. This is the list of the symbols we were planning.
Okay, so this has various kinds of, this is useful, I think, and could be really useful. These are various ways of transforming to graphs, to expressions, graphs, and this rules tree idea.
Yeah, so that was an idea to input the tree faster than writing one by one the tree elements.
Right. I mean, it's just a way of tree rules. It would just be a way of taking this and transforming it to something that just has a different structure, which might be more convenient for manipulation. Similarly with tree graph.
Right. The idea is node, rule, list of subnodes. And this can be iterated.
Right. Tree replace part and tree path. Yeah, tree path is a relevant thing here.
Yeah, that's a way of specifying any position, including reference to like parents, uncles, etc.
Where do you supply that? Where does tree path get used?
In other functions like replacement, etc.
Do you know if it's efficient? I mean, how is tree path and things like that implemented?
Yeah, this is not particularly efficient, but
it's being re-implemented now.
Yes, exactly. So what Stephen is using right now is a top-level prototype, and now the idea is to make this work using the graph functionality, which has already some code to handle trees.
Yeah, no, but I mean, the concept of tree path and parents and all of that is, I have also run into needing to reify that concept. And so that's interesting to be able to say that we have something like tree path that does represent that properly.
Yeah, and here we were fighting some particular problem, which was how to unify the language of part expressions and the language of position expressions.
Yeah.
And that's why we introduce a new head rather than having just lists, because there are 3 different concepts in which we use lists.
Yeah.
Okay, so let's keep going. I'm pretty pleased with this unification. I think this will work. You know, this is really going to help on both sides here. So let's keep going, because this also, presumably this text element representation should be easy to turn into a tree object. We may already have a mechanism for that, for text structure.
Yes, I think some particular expressions like text elements and associations were already special in the system.
Okay, all right, okay. Okay, so I understand. So there's a bunch of stuff to go back to what? I mean, you know, I could imagine that you're calling this something like parse tree, although I'm not sure that's the right.
Well, yeah, so one of the big things I want to get out of you, if I can, is your opinion about what the name of the function should be for being given a string and returning these, you know, the big tree node, whatever the trees end up being, what the name of the function should be.
Yeah, I understand. But that's okay, I get it. But if it's going to return a tree object, I'm thinking, I mean, I don't know whether it's string parse tree or something like that. I'm not sure. But
well, I don't know anything about, adding tree, but so I didn't know if parse by itself was too general.
There might be a file.
The word parse is not going to work on its own, but something which uses the word parse will work.
Sure.
But let's take a look at
there might be a file, or there might be a byte
I
array.
understand what there could be. Right.
Just saying.
Yeah, I got it. There's a byte array, there's a string, there's a file. I get it. Same thing with import. And it's not obvious that those things, I mean, import could perfectly well, you know, when you import a .wl file, this should be one of the elements of what you can get out.
Yep.
Okay, but now you've got tokenization, which is interesting and nice. All right, let's take a look here before we loop back to talking about these. So you've got the abstract parse, you've got concrete parse, you've got tokenization.
Yeah, these are the functions that exist.
Well, that's nice.
And what the question is, what should be? One thing that I wanted, obviously there could just be single functions for each of these given.
Okay, I get it.
Yeah.
I'm not ready to come back to that. I want to understand more about how this is used.
Sure.
Okay, so you've really managed to run it on all these things. That's great.
Oh, yeah. I mean, I have more confidence in this than, you know, other parser.
You do, yeah. Okay, all right. Okay,
so that's parsing. Let's put a line there, yeah. So then with linting, I'm already prepared for not having the word lint.
No, I understand. Well, let's take a look at the functionality. So you're returning. Okay, so this is something which there will be a front-end UI element that kind of invokes this.
Yeah.
And this is more the file report version of this, correct?
Well, I mean, that's...
By the time you have a line number, it's something to do with a file.
Well, I mean, with strings, you can have multiple lines also.
Sure.
You really do want to report lines.
Well, not when it's auto-formatted.
Well, no. Here, there's nothing about auto-form. It's taking that string that was given. There's nothing about
but I understand, but it's not going to be, if you're auto-formatting, everything's going to be on line 1. Anyway, this is a detail. There's a detail.
Yeah.
It's relevant for files. It's not relevant for in notebook type stuff, except in package files, package notebooks. Okay. So this is the analog of a failure object, but for a lint output object. Is that correct?
It is, yes. It is a question how this does compare to things like failure objects.
Well, it should have the same structure, I think. It isn't the same thing. It shouldn't be a failure object, but it should have the same structure.
And it does roughly. I mean, there's a tag
Doesn't
and
actually have the same structure.
association, but
Yeah, it doesn't.
Yeah.
I mean, okay.
so those are the functions, and we can discuss about that. Formatting is a little bit different because there are functions analogous to the other things we've been talking, strings, files, and bytes. But with formatting, there's a question of what the output should be when given a file, because an expectation is that you're modifying the file in place. That is different than strings and byte arrays, obviously being returned. And so just balancing that symmetry,
Well, I don't think that, I mean, we don't have a lot of things that return a file in place. I mean, that's
well,
not been,
that could be another question. Okay, maybe we don't even want to, sure, yeah.
What does
I mean, I think that's,
what does clang format do? Does that do
Well,
it?
you say -I to mean in place. But by default, if you don't supply the -I, it doesn't modify anything. It returns it to standard out. Right. And then with code assistance, this is another beast where we're now talking about interactivity, but maybe we don't even expose a function to do this because it's pretty obscure to begin with. But if we did expose a function, one thing that I would want to make clear is that this would not be specific to code only. And we could also be analyzing text cells, for example, along with input cells. So
what would we do with the text cell?
well, so if you create that document there, inside of that title, if you unformat that title cell, there's an invisible character that's an example that can cause, that's the function application Unicode character that can come about from copying and pasting PDFs outside. And so you could also warn about that sort of thing. And so any names that we come up with here probably
I get it. Well, also the spell checking
code. Yeah, exactly. I mean, similar. Yeah, I mean, exactly. Yeah.
All right. Okay. So let me understand then. I mean, our early target for this is interactive code assistance in the front end, right? So what we're talking about here is the language level representation of what's going on to support that feature. Yes.
That users may want to use.
Right. Okay. But that feature, we're on track to have some version of that feature. Yes.
I'm afraid that you're implying for version 12.1.
No, of course not.
Okay, then yes.
Ethan on our live stream is commenting on lint as a function, as something parallel to Wolfram script. Yeah, I mean, that's all of this stuff that is, language level is absolutely applicable to those command line things.
Oh yeah, standalone tools are definitely a goal.
Okay. All right. Let's start from the beginning again. Okay?
Sure.
Okay. Have you talked to John Fultz about the front end parser? And also, what about? Oh, okay. And what about Jan and the parser for the cloud?
I mean, just in very abstract terms.
But that's yet another parser, isn't it?
Yes.
So there are actually three.
Well, yes, but I mean, do we also count the workbench? Do we, I mean, there,
No, how many parsers do we
There-
have?
Lots of them.
yeah.
Are you asking how many we have deployed in products or how many
Yeah.
we have floating around the company? Even deployed in products, it would take some effort to think of how many. And you know, you have to understand the parsers also have different capabilities.
Yes.
So you know, the front end parser, for example, has a capability that none of the other parsers in production has, which is to robustly deal with syntactically wrong stuff.
Right.
But that is a goal of this one that we're talking
Right.
about here too, though.
That's I was being careful and saying none of the other parsers in production.
Yeah.
Yeah, I'm not excluding this one here.
Actually, the workbench parser does the same thing as well. So
Okay.
Okay.
Right.
Oh, yeah. That may very well be true. Yeah, you're right. As another example going the other direction, which is that the notebook front end has a mini Wolfram language parser for parsing notebooks, which does not, you know, it's not capable of parsing the full Wolfram language spec. It's just a subset of the spec.
That is for parsing the notebook source code.
Yes. So,
okay, so
the subset, the subset is fully correct, but it's, you know, far from complete. So
the first thing we need to understand is how do we get from, you know, this is basically it's the analog of to expression. I'm trying to think. So this is going to generate a so we have a string here, we have a byte array here. Those are distinguishable by their data types. I would guess the file thing is not. Right?
Well,
we'll use a file wrapper, surely.
yeah.
Yes, but the file wrapper, I see. Okay, fair enough. Fair enough.
I think that's fine.
Okay. Something is bothering me about this. No, I guess not. I guess this is not taking, I mean, I could imagine a held expression here, couldn't I?
Not for parsing. So there's a question about, well, I mean, it's already parsed.
Well, I understand that, but you might still want
there's a question about
tree
giving
representation.
that to the linter, you know, already parsed expressions. And I have a note down there if we want that. Parsing, I don't know if that matter, if we want that here or not.
Okay, but I mean, so in a first approximation, we could imagine something like this.
Well, no, because you definitely can't ask for the concrete syntax of an expression.
No, I got it. I'm talking about the second argument structure, and I'm talking about, you know, by the time you're talking about a concrete syntax tree, an aggregate syntax tree, an abstract syntax tree, there are syntax trees, you know, growing on trees, so to speak.
Yes.
And I don't think we want to start off with a bunch of top-level functions that represent those, because we may want to add variants to them, et cetera, et cetera, et cetera. So, I mean, So, I mean, the way I would think about it is, if we, so let's imagine that the objective is to create a tree object of this kind. Now, whether it needs an outer wrapper, I don't know. I mean, in your version, it doesn't have an outer wrapper. You just start with a string node. See what I'm saying?
Well, the string node, that's another question that I had. That is the outer wrapper. A question is what the outer wrappers should be called.
Well, if it even needs an outer wrapper. I mean, in other words,
I think it does.
Well, I'm not sure it does. And I mean, I think that as soon as you introduce one of those things, it reduces interoperability.
Well, the problem is we need to be able to handle you know, if you said parse tree, you know, you said 1 + 1, new line, 2 + 2.
No. The question of whether there's an outer wrapper, it's
you might actually be parsing more than one expression.
So what? Yeah, I understand that point. So, I mean, to me, that's a top level in this tree, and it's got to have a named tree element. But
Sure.
again, you know, you've got, let me make it even more complicated. Let's say you're parsing multiple expressions in multiple cells, then you've got to have yet another kind of element. You see what I'm saying?
Possibly, yes.
Definitely, because you don't want to, you want to represent those as a new line, you know, a cell, a new line, whatever, a cell group. Could get really quite complicated. I mean, I think another interesting question is to what extent this representation can also represent abstractly a notebook. Because what we've got in, I mean, for example, one thing I don't think we thought about is turning notebooks into trees. See what I'm saying? Jose, I don't think we thought about that.
No, certainly. I mean, I was now thinking whether we can represent itself, like a tree, using its own structure, something like that.
Yeah, I understand. But I mean, in terms of, but John, I mean, as we think about modernizing notebook manipulation, this is another, I mean, what we've got in, you know, the things that we're trying to do with notebook manipulation are very similar to the things we're trying to do with parsed expression manipulation, I think. Does that make sense?
Yeah, having been in the conversations about parse expression manipulation,
well, I mean, we're having
I
to
assume you're
find
talking about
pieces.
something aspirational as opposed to stuff we already have. Yeah,
I'm talking about a modernization of all of
the.
Well, I'm talking about a modernization of all of this kind of notebook. What am I saying? You know, replace this group in the notebook with this type thing, and so on.
Well, so certainly one of the things which we've been proceeding on, you know, in an independent fashion in notebook manipulation is, you know, the use of UUIDs to be able to uniquely identify parts of the notebook DOM.
Which is not what's happened here. It could happen here, but it isn't what's happened here. Right, Brenton?
I mean, we're not using the UUIDs. I'm not sure what you're asking.
Well, no, I mean, you could imagine.
Well, for the UUIDs to be useful, they have to be persistent in some way. I mean, like, you know, you know, Brenton's parser couldn't just generate UUIDs because,
yeah,
you know, it's, you know, the UUIDs have to have a you know, a good long lifetime.
Well, I understand that, but the point is that the UUIDs are representing something that the user sees on the screen that you can then pick at parts of.
Yes.
Okay. All right. Let's go back here. Okay. So I think what we're realizing. So let's imagine that we took this representation and we basically are using tree element for it.
Yeah.
Okay. So let's take a look at what that means. So we've got. I mean, I would use for that source thing. I mean, what is that? Isn't that string position?
Why is it line and column? I mean, one line is not interesting, but once you have multiple lines, it becomes more interesting.
I see. Okay, well, I mean, obviously it needs a name that is a little bit more indicative of. That's weird. I mean, I think that there should be a way of just getting the string position. I think that's going to be useful because otherwise you have to, you know, to go back and manipulate that. I don't think the obsession with multi-line, you know, I think that should be handled separately. I think what you should do, since these lines are independent, I would have thought you should split the lines first and then have essentially a list of different parse trees for the different lines, which means that then each line making sense. And then, for example, what you could do.
It's the easiest thing in the world to accidentally have an input that spans more than one line, though. I mean.
So what? I mean, so why do you care about? It's a mistake to do this with line numbers
You
burnt
definitely
in
have
so
string
deeply.
position. Don't get me wrong. Yeah.
But I mean, I think then what one might want to do, again, let's take a look. All right, so the basic idea would be that you have a bunch of tree elements, and you would say something like type arrow leaf node, something like that, and then you would say string position arrows number, something like that. And then you might say, well, you might have other decoration here. You might have other things that says, this is I don't know what it is, some kind of decoration about that node.
Yeah.
Right. And then you've got
with the string position, there's already a question of whether we say the end position is inclusive or exclusive, because it's very, very useful to count past the end of the thing you're talking about. But with string position and functions that take string positions, they're always inclusive. And so there's already a tension with, if I just had a single integer.
I understand. So we may have to have a different name for that.
Yes.
It might be useful that string take just took that thing out.
Yes, it would be useful. String take should just work to go from this. And I also think that my feeling would be, and again, maybe it's too inefficient to do this because it's to be able to have the actual source, but this doesn't quite make sense.
That's why you have string position.
Yeah.
I understand. So it can be.
The string position isn't the same as Brenton's, because this is starting from 1 at the beginning of the source.
I understand, which is what we want to do.
It's including return characters. Whereas what Brenton wants is each position is the position in the line, which is also totally useful. Right.
Various people on our live stream are asking for a formal spec for the language, which this should generate.
It's easier than ever before. A formal spec of the language could definitely be generated. Yeah.
And the code for this could be made available, right? Because this is
absolutely. We're working with getting everything up on GitHub. Yeah. Yep.
So I think finally that particular desire of having a formal specification will be there, even though what it parses into beyond the abstract syntax tree may be a different story.
Yeah.
Okay, but now here, so we've got this, and we have some details to work out with this.
Like I joke about a formal spec of the language. It's actually harder to tokenize Wolfram language than it is to parse tokens. Once you have tokens,
let's look at tokenization for a second.
It's actually easy.
Yeah, I understand that for the most part, depending on what you mean by a token. All right, so this is the tree version, and there's some details here about what, I would have imagined,
there might be some type above that's aggregate node or something.
Yes, I think that would be a good idea to have a wrapper that goes above that.
It's still a tree element, but
yes. Okay, so let's now take a look at your tokenization. Okay, so that is a separate thing where explain to me how, in this tree, you could imagine putting tokens in here, yes? That's sort of the point.
Well,
there's also a linear tokenization.
Yes, that's all that I'm talking about.
But you could as well represent in the tree each of these nodes in the tree.
Sure. As one big, long, yeah.
Well, no, but a token here, well, let's take a look at what your tokenization stuff does.
Scroll up. Scroll down. Tokens, yeah, just a little bit further down. And then here, right here, yeah. So it's just similar to parsing, there's just tokenizing, returning flat lists of what we've been talking about, which is also useful, particularly for Timothy, for example, for the machine learning people, to be able to grab this stuff quickly, where you're not dealing with the tree structure directly, but you're still working with the Wolfram language.
Right, so I understand. So this is a flattened version of the tree.
More or less, yeah.
Right, so in the tree manipulation system, what do we have that's along these lines? This would be effectively, I think, tree leaves.
Tea leaves.
Tree, not tea leaves.
Oh,
Tree,
yeah.
tree leaves.
I know, sorry.
Am I correct?
I mean,
Yeah,
I'm sure it's not tea leaves. I'm sure of that.
What are you talking about?
I'm just making a feeble joke.
Okay, good. I'm sure. Yeah.
My intuition of what tree leaves would do, I mean, yes, I would have to see it. I assume it does what we're expecting.
I would think so. I would think it just makes a list of the leaves of the tree in a depth first order.
Yes,
I assume
there was a discussion of whether to include the internal nodes or not. I think we parameterize this, but I don't remember.
Right, and I also imagine that we should parameterize the order of the tree walk.
Yes, indeed.
But I think that's what that is.
But it's important to realize you want the performance of being able to tokenize directly without having to go through.
I understand.
A whole, yeah. So.
Well, so the obvious way to do that is to say parse tree, and instead of concrete syntax, to just say token list here.
Yeah, for example, sure.
Now,
you're okay with having that different structure.
I don't know. I don't know. Okay. I mean, it's still, yeah, right. I mean, I'm not sure the name. So this particular thing would take in code, correct? It's not going to take other stuff in. Is that true?
Are you meaning strings, or what do you mean?
No. I mean, this is going to take a string or file or byte array that represents a piece of code, or it could take
code.
No. Well, it could be generalized to other things too. What's that? But it could also take the content of a cell, could it not? It could also take a notebook, a fragment of a notebook, potentially.
Yeah, I mean, we could think of things like that, but those things have already been parsed in some sense. And it's a question of what it is that we would be doing with it then.
One on our live stream wants to tokenize. Let's see, how do we tokenize? Do we have the, okay, tokenize string. Okay, that looks like a pretty harmless tokenization. The front end goes wild with it because it is considered a valid file name. Oh my gosh.
Well, technically, in the documentation, it says that square brackets have to be balanced.
Okay, all right. Well, okay, I'm sorry, let's come back out to this again, okay? Because I want to make sure that we have a path forward here that allows you to actually, redo the cosmetics of this so that we're ready to, to roll forward, so to speak. And I think Tony is the one who's now working on the trees project, right, Jose?
Yes, with help also from Ian Ford.
Okay, great. So Brenton, you should connect with those people.
Yeah, okay.
I think this will be really good because this is there's a real use case for the trees stuff. Okay, I also would like to suggest, which I hadn't really thought of before, of taking notebooks and turning them into trees. and understanding how that can be used in the trees project. Does that make sense? John, I mean, is there already existing code that effectively does that? In other words, you're making an abstract syntax tree for a notebook, otherwise known as a DOM structure.
Well, I guess I'm trying to figure out how is that different from the expression that we already have.
It's not very different. It might have some conveniences. In other words, in this collection of syntax trees here, there might be a notebook tree that has some other conveniences.
But the actual notebook expression is hard to understand as an actual tree. I mean, it is a tree, but it's the front end's format of notebooks. It's not quite what the notebook structure represents.
Well, I'm not sure about that. I mean, it's a bunch of cell groups and cells and so on. Anyway, I think it would be useful to see it in this form because I think that's a form in which it can be manipulated. All right, but let's come back over here. So the other big questions that you have.
I will say, by the way, just in terms of manipulation, the single biggest annoyance in manipulation is the fact that cell groups are embedded in the notebook expression. And
should be treeified.
If you want to do things like, for example, remove a cell, move a cell from one place to another.
Yeah, I understand.
You might hope for it just being a flat list of things, but it's definitely not.
Right. So the correct thing to do would be to have something that says in this parse tree mechanism, something which will take a notebook and parse it into an abstract tree that has that annoyance removed. And then be able to write it back out again in the same way that this can write back out its syntax tree out as a string. So similarly, you could write it back out as a notebook. And by the way, Ethan on our live stream is asking about, will this replace the XML functionality nightmare? I would hope so. That's also the goal of the trees project.
Well, a problem we face here is that some of these trees are going to be very large. So we started discussing how we could interact with the tree expression, like opening a branch, closing it, things like that. Whether we present them vertically,
visually?
horizontally. Yes.
Yeah, visually is one thing, and that's important. And elision of trees, like elision of large graphs, which is another project currently underway, right? A tree is much easier to elide than a graph, because a tree, you just say, below this node, we're not going to show it, right? And then you can, open that subtree and keep going. Am I making sense? By the way, various people on our live stream are asking about formatting. We have a separate but related project on formatting. This is not the formatting branch. This is the symbolic representation branch, which feeds into the formatting branch, but this isn't the formatting branch.
Just to be clear, like all this parsing stuff is used by the formatter that I'm working on.
By the way, this is very nice stuff, Brenton. Well done. I mean, I'm just it's okay, let's talk about the linter for a minute. So the issue is you've got an expression, or no, you've rather got a string, and you're going to produce commentary on the string, correct?
Yes, correct.
Okay, and that commentary is actually a very, what you should produce is potentially a very tagged object that a front end can pick up and use to attach to its actual representation of the input, correct?
I don't know how this relates to front end interaction currently.
Well, okay, so I'm going to say, I think that what has to happen is, yes, you have that message and it's all very beautiful, but the front end has to know that message relates to the thing at string position, blah, blah, blah. So that whatever front end display mechanism exists is able to attach it correctly. If it's a call out, line or something.
If we're talking about having if A, B, B in a cell that we're talking, that's something different.
No, what we're talking about here is you're generating a collection of what the underlying data for this is a collection of information about, is commentary on an abstract syntax tree, basically. Is that correct? Or is it commentary on a string?
It's not just abstract, it's all levels, because analysis.
Okay, fine. It's commentary on a concrete syntax tree.
Yeah.
Is that correct?
Yep, yeah.
That's the way you want to think about it.
Yeah.
So, in a sense, what needs to happen is that commentary, just like you've got a token list, you want a commentary list of some kind, which somehow, threads back to what the original string representation is. Because the reason you want that, sometimes you just want, okay, give me the list of comments. But often you'll want to know it relative to the original string representation so that, for example, the front end can have little arrows that point to those parts of the string. Does that make sense?
Yeah, that would be great to have, yes.
Okay.
I don't know how to do that.
Okay, so I'm making a suggestion here. So what I'm saying is, what you should think about is returning these linted things. This is, in a sense, merely a decorated tree. So in other words, you could imagine having the complete concrete syntax tree with everything in it, but in these payloads here, in these sort of head tags or whatever, you would have things that say, oh, this subtree has this issue associated with it. See what I'm saying?
Yeah. Okay. I thought you meant more visually speaking.
No, I'm not talking about the visual side of it. That's not the problem we're solving here. The problem we're solving here is the transport layer.
That's completely fine, yeah.
Right, so then the idea would be to unify this linting mechanism with the parse tree mechanism, and to basically say, and the token list mechanism, and basically say this is one of the options for, I don't think that's the only form that this will be in. I think eventually there'll be a bunch of convenience functions that are more direct than this. But in terms of thinking about the unified design for the whole thing, I think the right thing to do is to think about this parse tree object, which might not have that name in the end, and have one of its formats be something that either is a effectively, and it's a bad name, a lint list, so to speak,
yeah,
or have something which is a linted concrete syntax tree.
Yeah.
Now,
there is a question of lints. Problems can span over different nodes, though, too. And there might be a representation problem of how do you avoid needlessly duplicating lint annotations across multiple nodes. But maybe,
well, is the lint annotation a subtree? Does it annotate a subtree, or does it annotate disjoint nodes?
What we're seeing is what it does. It is annotating the line of the string you're talking about.
Okay, but that's, yeah, okay, fine. But what does it do at the level of the concrete syntax tree, which is where it's presumably actually living?
Well, generating a list of lints is not a problem at all. What comes out in the structure of those lint objects, for example, has the same source structure that we saw above, with line and column information. But that line and column information might not directly map to.
Okay, but when you're generating this stuff, it's happening at the level of the concrete syntax tree. That's where you have the rules, correct?
Yeah.
Right. So whatever those rules are, presumably they apply to a subtree.
Well, okay. So I think on the screen on the left is a good example. If we're talking about both branches of an if statement, for example, that's not the entire subtree, because
I understand, because the whole entire subtree is the thing that you've got little space indicators underneath. It's the entire if. Right.
Well, the subtree is the A, B, B, but I would prefer to only annotate B, B. Okay,
I think that's going to be a mistake.
Well, it's where the problem is, though. There's nothing.
No, I understand that. But so what I'm suggesting is, I'm thinking here,
Yeah. So, I mean,
The issue is
to map it directly to the tree.
The issue is that once you have said there are problems on these two sub-branches, the question is, how do you connect the problems on those two sub-branches? And one question is, how many levels down the tree can that problem occur? And it might, in this particular case, it's at one level. There's two bad actors, so to speak, out of your collection of 3 nodes.
Yeah.
Right? But it could be, I suspect, that the bad actor is hidden down part 221 on one branch and part 135 on the other branch.
Sure, yeah.
But that you know that the badness is visible. I mean, like, for example, I could imagine something where there's scoping problems. In a pretty big expression, there's a variable that has, where it's, like, for example, the things that turn red in something like...
Scoping's an obvious example.
Right, where it's pretty distant, right?
Yeah.
So I claim that that should be annotated at the level of the scoping construct, and that you shouldn't try to kind of rendezvous the things, by saying that part down at 1358 or something is really, is something that is conflictive with the thing at part position 21, that type of thing. I think it's a mistake to try to have those things wave flags at each other to say that they're connected.
Sure.
I think it's a better idea to go from the top level scoping construct and look at its subtree and say, these small subparts of its subtree have this connected issue. Now, the only question would be when you're down at, so here's a question. So you're analyzing the tree, and let's say you took out a subtree. And then the question is, which I don't think it's obvious what the answer should be, let's say you've got a scoping conflict, okay? And you've extracted a subtree, a deep subtree.
Do you mean shadowing, or what do you mean by
who knows what? I mean, all kinds of weird stuff.
Okay, fine.
I mean, I can probably make one up. I mean, if I say, f of x blank colon equals x plus y plus x blank, okay?
Sure. Yep.
There I've got some weird conflict.
Yep.
Right? Okay. So what I'm saying is, if you were to take, so this is where there's sort of an inheritance issue. This whole thing, clearly, as a complete tree, there is a conflict in part, whatever that is, 1, 1 or something, with part, whatever it is, 2, 3, whatever it is, right?
Yeah.
Okay. Now, let's imagine that you take this subtree out, right? That subtree no longer has a patent conflict, so to speak. Right? It has a latent conflict, but it does not have an explicit conflict. So my claim is the right thing to do in that case is that the full conflict descriptor is at the level of the whole tree here, right?
Yeah,
but that this thing has, what's that?
The set delayed. Yeah.
Yeah, right. The set delayed node. But that what happens is that this contains a shadow of the fact that there was a conflict. Now, we may subsequently want to ignore that conflict because that piece of code might be pasted into something for which there's no conflict at all. You see what I'm saying? But to record the fact that there was a conflict there seems useful, but I don't think that you want to try to, have the thing waving a flag at the other X blank to say, I'm conflicted with you, because who knows where those things will wind up.
Yeah, once we are talking about things that can persist, yes.
Okay. Well, but the point is that we're going to want to do manipulation on these things. And yeah, anyway, so that's my suggestion is that that the main issue comes as subtrees, that it's a dirty subtree, it's got something wrong with it. Now the sub-elements, the actual individual elements that have a problem should, as an advisory matter, record that they have a problem, because when they are detached, they will then know that they used to have a problem. But many things will choose to ignore those advisories. Does that make sense?
Yeah, I mean, it turns into a question of representation and how we do all of this efficiently.
Well, fair enough. But I mean, I don't know how you I would think that the fundamental thing you're doing is stuffing advisory data into these heads. Right, which I don't think, and you know, the question of how you do that and how you maintain shared pointers to things, I don't know. But that's, I think, what it should do user-wise. That's what it should appear to be doing. Okay, so let's go back down here. In terms of what these messages look like, what we need, and we'll need it also for the function repository and so on, we need some symbolic representation of those message blobs, which, you know, we don't yet. I assume that we have that somewhere in the system. I think we should expose that. And whatever that is, we should use that to be the thing that is even contained in, I mean, I think it reminds me of Interpreter, which has a whole mechanism for, I mean, because, you know, Interpreter has multilingual support and God knows what else for dealing with error cases. Am I making sense? So what Interpreter does,
yeah, I thought failure objects just came back.
What's that?
Yeah, I mean, I just thought that.
Yes, but the important point is that they contain message tags that can be used. That message tag is used in practice by the form function to actually give you what the message should be when the form is used.
Yeah.
Okay.
So if you scroll down on the left, I have a list of possible names of objects, what these can be, all of under the assumption that lint is probably not the one that's going to live in the product.
It's not obvious to me that this shouldn't just be a failure object.
Well, fine. Sure.
I mean, maybe it's a warning object or something. I don't know.
Yeah, I mean, just the word failure is what I'm talking about. Yeah.
Well, I understand that, but I think, you know, the difference between a warning, a remark, a hint, an indication of suggestion, these are all shades of something.
Yes.
These are all shades of commentary, basically.
Commentary object.
Yeah, possibly.
So I think the most general.
But I mean, that's, yeah, go ahead.
Issue.
No way. No way. Issue has too many other meanings of, you know, issue. Things issue forth, so to speak.
Well, that's why we say object. Well, okay, if you meant, okay, yeah, fine.
I think that's not the right thing. I think that the better thing would be something. Okay, so another metaphor that we have is annotation.
Yeah.
And we're using annotation now to be something that is very close to what you're talking about. It is something where you've got like an audio stream, and you want to annotate a part of that audio stream to say Brenton was talking at that point.
Yeah.
Or you can annotate a graph. And I think, so here's an interesting question. For our trees, what is the interaction between annotation constructs and our trees? I think this is the place to go with this. Not completely sure all the pieces, but I think that's the place to go, is to use the annotation calculus that we already have. Because let me point out that there is a, you know, this whole question about what do you keep, what do you throw away? That's part of our annotation calculus for graphs. Okay, so let's imagine that you've done, you've colored a node blue, and then you find a subgraph, okay? Okay, you probably keep the blueness of the node. Let's say that you color a node blue and then you find a graph intersection with another graph where that node isn't colored blue. What do you do? See what I'm saying?
Yeah.
And the same thing will come up with these trees. That is, for example, let me give you an example. You would have something where the X blank, you're comparing, let's say you're doing some auto grading. You're comparing two expressions, and one of them came from something where there was an advisory thing that said this X blank is probably in the wrong place. But by the time you're looking at the subtree, all is hunky-dory. And then the question is, do you keep that annotation? Do you throw it away? What do you do? Depends on the operation you're doing, how you treat that annotation. I think this is the place to go. I'm not completely sure of all the I dotting and T crossing, but I think we've got a whole system And one of the things that's nice is we've got a system for inserting annotations, which will be very useful for these parse trees, right? Because then you can have analysis code that basically injects annotations that says, you know, I think this piece of code is bad in this place, and so on.
I mean, as long as it's efficient.
Well, better be, because it's being used for graphs, which are big. Why don't you go find out how that stuff works? This is a Charles Shardy production.
Yeah.
Okay, I think we run out of time for this particular meeting. This is really terrific stuff. And I'd like to, why don't you do one iteration, learning about what's been done with trees, learning about what's been done with annotations. And then let's come back to this and try and do another round of design on this.
Sure.
But this is really nice. And I think, I mean, hopefully with the trees project also being active, these things can connect well. All right. Oh gosh, we're really over time here. Okay, terrific. By the way, for people on the live stream, you might be interested to know on Monday, we have another product suggestions and priorities at 4 p.m. Eastern US time.
Maybe that one will be less than 3 hours.
Was the other one 3 hours? That's horrifying.
Well, I think it was about 2:40 or something like that. Yeah.
Okay. Well, that was very useful. A lot of good suggestions. We appreciate it. Okay. Sounds good. All right. Very nice, Brenton. Very nice.
Cool. Thank you. Thank you.
Okay. All right. See you all soon. Thanks for the comments on the live stream. And there were a few comments there, Brenton, you might want to look at.